Good morning, learners. Good morning. We'll be having basic science this morning for GSS 2. Basic science for GSS 2, and our topic is energy and power. Energy and power. Okay. Our objective says we should explain work. We should analyze the difference between energy and power, and also state the difference between potential energy and kinetic energy. Okay, that's our objective. Explain work, difference between energy and power, then the difference between potential energy and kinetic energy. Let's look at the meaning of the word power. Now, the definition here says, work is done when a force causes an object to move from one point to another. Before you can say you've worked, it means that you have applied a force, and that force is causing that thing or the object to move from one point to another. For example, now if you have a vehicle and you want to go out and there is need for you to push the vehicle, if you stand there and keep pushing the vehicle, you're applying force. If that vehicle does not move, work is not yet done. Until the vehicle moves, that is when you can say work has been done, because of the definition that says work is done when the force causes an object to move from one point to another. So even if you apply force and there is no movement, work has not yet been done. The amount of work done is the product of the force and the distance moved in the direction of the force. Now, it's still relating to the first thing I said. Before you can measure the amount of work that you have done, it definitely means that there must be movement, because it is the movement that will now determine how many distance that object has moved. So that is why the statement is saying that the amount of work done is the product of the force and the distance moved in the direction of the force. So now you use if you want to calculate the work done there, you look at the distance that the object has moved. You also measure the amount of force that you have applied. Now, this word energy and power. The word energy and power has to do with work as well. In work, you are applying force, and people tend to mistake these three terms to be the same thing, though they work hand in hand, but they do not mean the same thing. Energy and power are two different terms, but in the case of work, you will use the two words. The difference between energy and power is clear. As you all know before now, that energy is the ability to do work. Even a child in basic class can define it. But it goes more than that. Aside just the definition that it is the ability to do work, it also says that for a body to do work, energy has to be transferred to it. You have to transfer energy to something before you can say you have work. You don't just look at maybe for example you want to move your table to another point. Mere looking at it will not just move it. You have to apply energy. So now, what is helping you to lift the table now is the energy. So that is why we say it is the ability to do work. And energy exists in different forms. We have the mechanical energy, the magnetic, chemical, nuclear energy, and all of that. While power is the rate at which energy is used up. Remember I said energy is the ability to do work. Power is the rate at which energy is used up. Let me cite an example to explain that. When you move a table, what is helping you to move that table is the energy. The rate at which you have moved that table now is the power. If I have a stopwatch and you are to move the table, to one point to another point. The moment you move it to another point, you are applying energy. Now, the stopwatch I'm looking at, if it starts from 1 second, if you are able to move the table from 1 second to 10 seconds, that is the rate at which you have worked. So the time now, the rate is what is called the power. Energy is the ability to do work. Power is the rate at which energy is used up. When you keep doing the work, doing it, when you are tired, when you can't do it again, it means the rate at which you have used your energy is now the power. Okay, and an example says if a boy and a girl in your class move the same book from one point to another, then the two of them have done the same work. If a boy and a girl in your class are to move a table or a book from one point to another, if they do it at the same time, they have worked, they have applied energy, and the rate at which they do that work is the power. However, if the girl moves the book faster than the boy, then the girl is said to have used more power than the boy. If the girl is able to move the book faster, like if the girl moves the book in 3 seconds and the boy moves the book in let's say 10 seconds, the girl has worked more than the boy, because the rate at which she does the work is more okay than the way the boy has done it. So now, before you can say you've worked, there must be movement, there must be distance covered, so we can measure up energy and power. Okay, that's it for energy and power. Under the same energy, we have under the mechanical energy, we have what we call mechanical energy. Is actually classified into two. We have the potential energy and the kinetic energy. So potential energy and kinetic energy are classified under mechanical energy. Now let's look at the difference between them. Potential energy, this is the energy a body possesses because of its motion. The type of energy possesses because of its position is what we call the potential energy. Potential energy has to do with position, while kinetic energy is the energy a body possesses because of its motion. So these two words are different. Potential energy is talking about position, while kinetic energy is talking about motion. And a suitable example for potential energy is a stagnant table. A table that is placed in one place possesses what we call the potential energy. A mango on the tree possesses potential energy. So every object that is at rest, every object in a position that is not moving possesses potential energy. If you're standing at a spot, you're possessing potential energy. But kinetic energy has to do with motion. A catapult that has been flinged with a stone possesses kinetic energy. A running girl on the field possesses kinetic energy. So every object that is not in position, that is moving, possesses kinetic energy. Another example for kinetic energy can be our vehicles, our cars. Once a car is at rest, once a car is parked, it is in potential energy. But the moment it moves, the moment it is moving, it is existing in what? In kinetic energy. So don't forget. In summary and conclusion, I said energy is the ability to do work. Power is the rate at which energy is being used up, or the rate at which work is done. And under the type of energy, as for mechanical energy, it is classified into two. And those two are potential energy and kinetic energy. And I said that potential energy has to do with position, an object that is at rest. And kinetic energy has to do with object in motion. An example for potential energy is a stagnant table, a table at rest, and for kinetic energy is a moving car. So try and know the difference between these two. Try and know the difference between power and energy, difference between potential and kinetic energy. Alright, your assignment. If a hammer is to fasten a nail into a wood, if you have a nail on top of a wood and you want to use the hammer to drive or fasten the nail inside that wood, describe the type of energy that is being transferred. Is it kinetic energy? Is it potential energy? So the assignment is saying describe the energy transferred when a hammer is used to fasten a nail into wood. Thank you. I await your response on the assignment. Thank you.